This is 2-6, inequalities involving absolute value. So remember that when we had absolute value equations, like x plus 2 was equal to 10, we had to write two equations, x plus 2 equals 10, and x plus 2 equals negative 10, because what was in the absolute value bars could have equaled 10 or negative 10. And then we solve both of these, and we'd get x equals 8, and x equals negative 12, and in set builder notation, we had 8 and negative 12. Okay, now, the other thing you need to remember is more recent, which was that the less than and for less than was an intersection, and then I'm going to go with greater. So I'm obviously making these up, but greater was the union, and that was the or. Okay, so we're going to need to know that for this. So I see already in example 1a that this is a less than sign. So I know this is going to be an and, which would look like, I had told you guys, small number, less than or less than or equal to x, less than or less than or equal to big number. That's how you'd have to write your final answer. So let's look at this. If we have case 1, 3p minus 12, we keep it the same, less than 9. I just drop the bars. In case 2, 3p minus 12, we're going to flip the sign and make it negative. So greater than, and the 9 is going to become negative 9. So it's a flip with that negative, and we're making it the opposite sign. Okay, now we would solve both of these. So plus 12, 3p is less than 21, divide by 3, and p is less than 7. And then on the right, we would add 12, 3p is greater than 3, divide by 3, divide by 3, p is greater than 1. So if we write this answer, the 1 is the smaller number. And so I would write that first. So I'd have 1, it's just less than, not equal to, p, and then less than 7. So that was the small number 1, less than the variable, less than the big number 7. So that's where all this is coming from. And then graphing that, we know what it would look like. It would look like an intersection. So open circle at 1, open circle at 7, and it would be in between these two. Really stress where the solutions are. So p could be any number in between there. Okay, example 1b. Here we need to remember that the absolute value bars need to be isolated before we can write the two cases. So I'm subtracting 3 to both sides first, and this becomes absolute value of x is less than 9. Now I can write my two cases. Case 1, x is less than 9. Case 2, it would be flip the inequality sign and make the number negative. And these are already solved, so I'm done, except I have to write my final solution. This was a less than, so I know it's an and. So again, I'm going to use small number, negative 9, less than x, less than big number, which was 9 in this case. And on a graph, these numbers aren't here. So we could just white that out, put new numbers like that, and then it would be open circle, and it's an intersection. So go in between the two. Okay, this original inequality symbol is greater. Remember, greater. So this one's going to be an or. So I know my final answer is going to have or in between the two statements. So I would have x minus 5 is greater than 4. And then case 2 is going to be flip the inequality sign and change the 4 to negative. Solve like normal. So x is greater than 9. Add 5 to both sides here. X is less than 1. And so then I can just write those here. Doesn't really matter the order. Some people would put the smaller number first, but it doesn't matter with the or. So x is less than 1 would look like this. And x is greater than 9 would look like that. like oars on a boat. Let's look at B. So my absolute value bars aren't isolated, so I can't write my case yet. So I have to get rid of this plus 3 first. So it's going to be x plus 2 greater than or equal to 10. Okay, so now I can write my cases. X plus 2 is greater than or equal to 10. X plus 2 is less than or equal to, and the 10 becomes negative. Solve these. X is greater than or equal to 8. X is less than or equal to negative 12. And is this an and or an or? The way that we know that is we look at this original inequality symbol, and it was an or, so it's going to be greater. So I know it's greater than, so it's going to be or. I don't know what I said there. Okay, so x is greater than or equal to 8, or x is less than or equal to negative 12. So what that looks like on the graph, we'll just pretend we've got, how can I do this quickly here? We'd have to change these numbers, but just to save you time, there's that going that way. And greater than or equal to 8 would be closed circle going to the right. And we're not going to worry about word problems yet, so you can skip example 3. Go on to example 4. Okay, when we have a negative to the right, if you remember when we did equations like look on the top left here, absolute value of x plus 2 is equal to negative 10. We said that was never possible because what's in the bars right here, the x plus 2, whatever's in here, could never be equal to a negative. Now it's a little bit different for the inequalities. You have to look and see. So if this number, don't look at the x plus 5, just think, whatever's here, when it comes out as a positive number, could the positive number ever be less than negative 10? Because the answer is no, this is no solution. So you'll never have a less than a negative number. Could a positive number be greater than or equal to negative 4? Yes, it could. That's true. So if it's less than, it's going to be no solution. If it's greater than, it's going to be greater than a positive. If it's greater than a negative number, or just greater than a negative, that's always going to be true. If it's less than a negative or less than or equal to a negative, it's always going to be no solution. So if that helps, you can memorize it. But for me, I just think about whatever's in the absolute value I know is going to become positive, so I don't care what's there. Just positive number. Is it greater than or equal to negative 4? Yes, it is, so it's true.